Hello and welcome. My name is Megan Van Emmen, Extension Beef Cattle Specialist with Montana State University, and today I'm going to be discussing delivery of minerals and determining intake in beef cattle production. First here is delivery and analysis. So there are several ways to deliver minerals to your beef cattle. Free choice in your total mixed ration, in a supplement, as an injectable, or as an oral drench. Now there are pros and cons with each of these methods, so you just need to work out which would be most beneficial, economical, and best for your operation to determine how to feed or deliver those minerals. Now for trace mineral analysis, the big one and the most accurate is collecting liver biopsies. This is a surgical procedure, so you would need your veterinarian to conduct these liver biopsies, but it's very informative as well as accurate in determining if your cattle are deficient, adequate, or marginally deficient on their trace minerals. Having that relationship with your veterinarian, and they can come and collect a subsample from your cattle herd. So I would recommend about 10% of your cattle herd be sampled if you're going to do this method of analysis. So I would look at doing, if you had 100 cows, I would at least do 10 of those cows, and make sure that you collect from your entire herd as a representation, not just your best looking cows. We want to get an accurate picture of your trace mineral status of your herd. Now, another method is collecting blood samples. It's easy to do. Trace mineral analysis in general is expensive, so there's no real cost difference between a blood sample and a liver sample. However, it's just easier and may not require a veterinarian to collect those blood samples as long as you have the correct tools. And however, it is only somewhat accurate for trace minerals, and the most accurate being that from zinc. However, for most of our trace minerals, collecting a blood sample really isn't going to be that accurate, because what is occurring is if your animals are deficient, those livestock are pulling their trace mineral storage from their liver first to maintain circulating levels. And so your circulating levels may indicate that trace mineral status is adequate. However, based on the liver storage, may indicate deficiency. So just something to keep in mind if you think you might have a mineral issue going on. Liver biopsies are going to be your best bet on determining trace mineral status. As well as then with the blood samples, that does require a special blood sample tube, and it's a royal blue top tube, and that is strictly for trace mineral analysis. We can't just use a regular red top type blood tube for our trace mineral analysis. Now, if we're thinking about mineral tags, there's several things to consider. Such as, is it a complete mineral, meaning it includes salt, or is it a mineral concentrate, meaning that it does not include salt? So those mineral concentrates, they're going to suggest you add salt to them, and that is mainly for palatability. Mineral concentrates are not palatable, and so adding that salt can entice intake of those minerals and help reach a target intake of consumption. Also on your mineral tags, you'll want to look at what type of mineral sources you have available. So you're going to have organic sources or organic chelates, which are sources such as zinc proteinate, zinc methionine, any of those that are chelated or attached to a protein or an amino acid. Are going to be organic sources. Now, your inorganic sources are things like zinc sulfate, copper sulfate, magnesium oxide, and things like that. So looking at your mineral sources can help determine how bioavailable that mineral is going to be for your cattle. So the more organic sources or concentrations in the mineral supplement, it's going to be more bioavailable for that animal, so better absorption versus your inorganic sources, which are still good sources of minerals. They just aren't as bioavailable as our organic chelates. Most minerals contain a mixture of organic and inorganic because organic minerals are expensive. So we want to mix inorganics with them to make it more cost effective for you as a producer. The tags aren't going to tell you how much organic or inorganic are in that mineral supplement. And then the next one is to look at those mineral tags and determine if that mineral is best fit for your feeding environment. Basically meaning a dry lot or feedlot versus a pasture source. The big one is the time of year of when you're going to be feeding these minerals to determine how best to fit them into your feeding program. As we've pointed out in our macro minerals webinar, so time of year would be like in the spring, we would want a mineral that contains additional magnesium due to our lush green forages not having sufficient magnesium. Or in the fall, as our forages mature, we would want an additional potassium source. Knowing where your cattle are, not only in the pasture versus dry lot, but also in their reproduction cycle. So are our cows lactating versus gestating? Are we into pre-calving, so where our mineral demands will also be increasing? Just things to think about that we might have to change our mineral program throughout the year to meet the requirements of our cattle and to best fit our feeding programs. And then, are our cows consuming the mineral at a recommended intake level? If it's a complete mineral, especially a loose mineral, that general recommendation is between 2 and 4 ounces per head per day. Now, here's an example. This is an injectable mineral. So a positive for the injectable is that we know exactly how much mineral we are giving our herd every time we give this injection. However, injectables are made to be supplements. They are not a replacement for a mineral program. So as we can look up here in the top left, this injectable only contains 4 trace minerals: zinc, manganese, selenium, and copper. It also gives our recommendations here on how to administer and how much to administer those animals throughout the year. So this is a good supplemental program to our current mineral program for your herd. So that's just something to keep in mind if you are using injectable sources. They are a supplement, they are not a complete replacement. So here is an example of a feed mineral. So this is in a protein type supplement. So a lot of our commercial supplements, especially like range cubes, lick blocks, things like that, contain a vitamin and mineral package. So we have calcium, phosphorus. There is no salt added here. So this is a higher magnesium mineral, so we're looking more in the spring. We have some potassium, cobalt, copper, iodine, manganese, selenium, and zinc, all included in this mineral. Just a few things here. Like I said, we want to look, do we need to add salt? Pretty decent protein here, so it's a good overall supplement for our cattle as an additional feed source. Just another example here with calcium, phosphorus. Now this one does include salt. So most of the time our salts are included to limit intake of self-fed supplements. So that is why salt is here, to control intake and hopefully shoot for the optimum intake for your herd. Once again, we have magnesium included, cobalt, copper, iodine, manganese, selenium, and zinc, and then our vitamins A, D, and E. So, as stated previously, we have inorganic versus organic. So we have inorganic mineral salts such as phosphates, sulfates, carbonates, chlorides, oxides. One thing to keep in mind is that oxides are typically less available than some of these other inorganic sources, as well as then on a magnesium oxide note, it's very unpalatable. It's very bitter. And then we have our organic chelated minerals. So it's basically a mineral that is attached to a protein, a polysaccharide, or an amino acid. And those labels will include things like amino acid complex, proteinate. They will maybe list a specific amino acid, such as methionine. As stated previously, most of our minerals have a combination of both inorganic and organic to be more cost effective for you as a producer. And then our organics are more bioavailable to the cattle. So I know this is a little blurry, but just as we look at this ingredient list for a mineral, so molasses products, usually a molasses-based tub, so we have plant protein products, but where I would like to focus, this is the inorganic source, cobalt carbonate, and this is our organic source, cobalt proteinate. We have three sources of zinc: zinc oxide, zinc sulfate, zinc proteinate. These are a mixture of inorganic and organic sources again. The same with copper. So we have a mixture in here to make it more cost effective to the producer. As we look at intake level here, so like I said, most of our loose minerals recommend an intake of 2 to 4 ounces per head per day. So to put that on pounds, that's 0.125 to 0.25 pounds per head per day. So for one animal, that's between 45 and 91 pounds per head per year. So basically, if you get it in a 50-pound bag, one cow is going to consume one of those bags every year to help meet her mineral needs. Just to give a rough estimate here, mineral cost, let's say, be between a quarter and 50 cents per pound. So at 45 pounds per head per year, that can range between $11 and $22. Or if they're on the higher end, they're consuming close to that 4 ounces per head per day. That can be about $23 and $45 per head per year for a mineral cost per head. So minerals tend to be the single most expensive ingredient. However, they are some of the most important ingredients we can feed our animals to maintain optimal production. Maintain those cows throughout the year so they rebreed. They have a calf hopefully within that first cycle every year, and they maintain their production, and that calf has good growth through the summer. We get a good calf at weaning time. Now, one thing to keep in mind, as I've pointed out previously in our kind of macro and micro mineral webinars, is that there are no bull requirements, but that does not mean bulls do not require minerals. They do have requirements, and that is extremely important for their reproduction purposes. So keep that in mind. Don't forget about your bulls throughout the year. They also need a mineral source, and that helps with sperm production, sperm normality, libido, and all of their reproduction purposes, so they can go out and do their job during the breeding season. So there's several things impacting mineral intake, such as the requirements, obviously, soil conditions, and mineral concentrations in those soils, which also impact our forage or other crop mineral concentrations, forage type and availability, what time of the year is it? Energy and protein supplements can also affect mineral intake. What is our water mineral content? How palatable is that mineral? What form is it in? Is it in a lick-type block, or is it in a loose mineral form? How fresh is your mineral supplement? I typically recommend only purchasing enough mineral for 6 or 7 months at a time. Um, that mineral that maybe has been sitting in the barn for 3 or 4 years, most likely those minerals are oxidized and are not able to be absorbed by your livestock. So I would totally recommend purchasing new fresh mineral. So keeping that mineral fresh can help with intake. And then location and access to supplements. So putting the mineral in places where cattle congregate, whether that's near a water source or in a bedding area, and making sure you have enough tubs, whether that's loose mineral tub or a like lick-based tub supplement, that all your cattle have access to that supplement, ensuring you have an adequate number of tubs available for all your herd. This ensures that the first cow into the water source gets her mineral as well as the last cow into the water source. Now, we can also use mineral supplements to pull those animals into areas of the pasture that are underutilized as well. So we can move our mineral around and get better pasture utilization. But one thing to keep in mind, if you're using something like a loose mineral, ensuring that there is a cover on that mineral, or you're using a mineral feeding apparatus that allows moisture to drain, but also doesn't allow moisture to penetrate that loose mineral. It makes it very unpalatable for the cattle, but also just keeps the freshness available for those cattle as well. Once that mineral, the loose mineral gets wet, it can basically harden into a block, and most likely they aren't going to consume what they need every day. So if you're trying to determine if a mineral is going to meet your requirements for your cattle, first things we need to know are what are the requirements of your cattle. Now, what are their age? Where are they reproductively in the year? We would like to know the biological availability of the mineral source. However, because we don't know the proportions of inorganic to organic, we just are going to have to assume that 100% of the mineral is bioavailable. And then from the tag, how much mineral should those cattle take in every day? How much are they eating total? So total dry matter intake, and that includes pasture, which we can do some rough estimates there. But this also then requires the concentration of minerals, not only in the mineral supplement, but your water and your other feed sources, such as the pasture or hay source. Now, some of these, especially common feed ingredients, we can use some book values. However, to get the best accurate picture, then I would recommend getting a mineral analysis completed on your feeds. So we're just going to look at copper here, and we can do any mineral you would like. Copper requirement is 10 parts per million, no matter what class of cattle you have. So we've collected our forage sample, and most of our forages in Montana tend to be below copper requirements. So for instance, this forage was 4 parts per million. Our supplement, which is on the tag, says copper is included at 2,200 parts per million. We need to know how much in dry matter these animals are consuming every day. So for the forage, we estimate our cow consuming 2% of her body weight. She's a 1,400-pound cow, which means she's going to eat 28 pounds of that forage dry matter every day. For our supplement, she's going to eat 4 ounces per day, so 0.25 pounds. So we need to convert everything to the metric system. So 1 pound is 0.454 kilograms. So forage intake in kilograms, so 28 pounds times 0.454 equals 12.7 kilograms. We do the same with our mineral supplement, and we get 0.11 kilograms. Now that we have our kilograms, we need to put everything on a milligram per kilogram basis. Well, this is fairly simple because parts per million equals milligrams per kilogram. So 1 part per million equals 1 milligram per kilogram. So those numbers actually stay the same. So now we need to calculate how much copper in both the forage and the mineral our cattle are consuming every day. So we have 12.7 kilograms times 4 milligrams per kilogram. Multiplication here, so we have 50.8 milligrams from our forage. We do the same calculation with our mineral supplement, and we get 242 milligrams. We total those. 50.8 plus 242 gets us 292.8 milligrams of copper per head per day. So this is why we need to know how much dry matter our cattle are consuming every day. So for total dry matter intake, we have 12.7 kilograms of forage plus 0.11 kilograms of supplement gets us 12.81 kilograms. So to get us back on a part per million basis or milligrams per kilogram, we divide 292.8 milligrams of copper divided by 12.81 kilograms of total dry matter intake gets us to 22.9 milligrams per kilogram or 22.9 parts per million. So we're meeting our 10 part per million requirement. Now, like I said previously in the last slide, this does not take into account any sort of bioavailability. So that could be less when we consider absorption. However, based on intake, we are meeting those requirements every day. Now, as another example, let's say our supplement only contains 750 parts per million copper. We're going to walk through the exact same steps. So intake is the same. Recommended intake is all of the same. So once again, we're looking at milligrams per kilogram. And this time, our supplement is only providing 82.5 milligrams of copper. We add those together, we get 133.3 milligrams of copper per head per day. Do the same math, and now we only get 10.4 milligrams per kilogram. Now, we are still meeting our 10 part per million requirement. However, we need to think in things like bioavailability of that copper source within that mineral supplement. But now we need to think of things along the lines of antagonists such as sulfur, iron, and zinc, which could have a negative impact on copper absorption. So if we have excessive amounts of those minerals, we could potentially reduce the bioavailability of copper. So similar example, what happens if our cattle are not consuming 4 ounces per head per day and they're only consuming 2 ounces per head per day? So 0.13 pounds of intake of that mineral supplement gets us to 0.06 kilograms. So basically half of what they would be consuming otherwise, which only gets us to 45 milligrams of copper. Totaling for total copper intake with the forage and our mineral supplement, 95.8. We divide again by 12.81 kilograms total dry matter intake, which only gets us 7.5 parts per million copper intake per head per day. So in this situation, we would not be meeting those copper requirements of our cattle. So this is how knowing intake of these minerals can really help us determine if we're meeting copper requirements or other mineral requirements of our cattle every day. So monitoring mineral intake, how often are you putting out new mineral or a new lick tub or however you're getting that mineral into those animals. Keeping those records so you can determine if they're on an adequate intake or not. So this is just some simple math you can do when trying to determine which mineral is going to be best for your operation. So I tend to get a lot of questions on when is the best opportunity to use mineral, because it's expensive, and we're just looking for those critical times of when we really need that mineral available to those animals. If I have to make those recommendations, 30 to 60 days pre-calving, 30 to 60 days pre-breeding, and that's cows, heifers, and don't forget your bulls. And then we're going to feed it at weaning, or at any time they're consuming low quality forages when they may not get adequate minerals from those forages. So if we start looking this on a yearly basis, if we're doing 30 to 60 days pre-calving and 30 to 60 days prior to breeding, well, we might as well feed it for that whole 120-day period. We want it at weaning to give those calves the best chance at entering the feedlot, or during that stress event, we want to feed that for, 45 to 60 days post-weaning to give them the best opportunity to succeed. Well, by that time, we're consuming low-quality forages basically for the next 6 to 8 months. So when you start considering all of this, we should always be supplementing our minerals. This ensures that we are feeding our cattle to have optimum production, but we want to make sure that those cows always have the ability to consume mineral to meet their needs and maintain their optimum storage in the liver, so during high stress events we can have something to rely on. So it may not happen tomorrow with deficiency if you haven't supplemented mineral, but it could occur due to a high stress event and those animals not having adequate storage available to draw from. With that, I'm Megan Van Emmen, Extension Beef Cattle Specialist with Montana State University. Thanks and have a great day.